Good evening. Hopefully everyone is well. Hang on just a second here. Let me get my stuff straightened out. All right, there we go. Okay. So hopefully everyone has been able to move through the exam, or at least had a chance to look at it. Because if you haven't at this point, you're probably a little bit behind the eight ball. Or I guess just behind. Something is strange here. I'm not seeing my playback properly. Yeah, well, looks like it's working, so it just wasn't loading correctly on my end. Oh, that's weird why it's not working. There it goes. All right, so I'm still getting used to the tools and how they work. Maybe that's something I could talk about, all the things I'm going to end up learning by the end of the semester, all the different tricks. All right, so so we left off last time. We talked a little bit about Maria, and I showed you an example. And we'll come back to that in a little bit. But before I get too far in it, I went through all the different, what do they call it, register transfer situations, and those aren't all the commands that we have. We actually have more than that, and we'll talk about that actually as we get there. So but first off, what I want to do is I want to talk about kind of the idea, what's going on inside of here, and so what I'm going to do is I'm going to go back to an idea that we talked about fairly early in the semester, and that is the fetch, decode, execute. We're really not slaying the code. I mean, although some of you might be very good at that. Right, in the different sense of the meaning, right? Anyways. So this is, the cycle. Sorry, cycle. I need to put that on here, cycle. Because this is a cycle. So it's going to fetch, it's going to decode, it's going to execute, and probably it's going to store that somewhere. And so sometimes we add in a fourth one, and that's called store. But that's not necessary. And so I'm going to go through, I'm going to draw a diagram. The diagram exists in the book on page 245. So if you have a book, you can open up to that page and you're going to see this. It's probably going to look a lot nicer than what I'm going to end up with. I wonder. Oh, you know what? I've got these little shapes here that I can use. This is actually super cool. So maybe mine is going to come out looking okay. All right. So this. All right. Good. And I'm going to call this the start. Except for I want that bigger. What is my font? Learning. Maybe I just grab this and make it bigger. No, that's not going to help. Resize. No, that's not the problem. What I'm... Okay, that's going away, and I'm just going to draw in there. Okay, so start. Okay, so I didn't talk about some of the... okay, not going to worry about it. Okay, so then the next thing we're going to have here, there's some material that was in the book that I could have missed. And that's okay, because we can't cover everything. Okay, so I need that done. Okay, so then I can get an arrow here. I can do that. Hey, look at that. Looks nice. All right, so, boy, this is going to be maybe too big, but that's okay. All right. So I'm going to do some shorthand. And so but I'm going to read the whole thing. Okay, so what I want to do is I want to copy everything that's in the PC, right? And recall the PC is the program counter. And I want to store that in the MAR, right? And recall what the MAR is the memory address register. Okay, so remember how I can do that. I'm just going to go like this, MAR, and I have an arrow there, and I get the PC. So the program counter is wherever we start. So I don't know, don't care, or wherever we are currently, and we're going to see that here in a second. Okay, so the oval here represents just kind of a position. These squares represent something that we're going to do, and then we're going to come into one that's a diamond. It's actually right here, and the diamonds are decisions that have to be made. Okay, so the next one we have, I'm going to make it about the same size. There we go. Okay, and in this one, we're going to copy the contents of the memory at address MAR, and we're going to put that in the IR. What's the IR? The IR, what is the instruction register, right? Let me go back to my notes here, just to make sure. Yeah, instruction register. So that tells us what we're going to do, and it keeps track of that. So again, see, MAR is just that place to store the address of what's out there. And so we're going to go, if I can get my mouse back in here somewhere. Man. IR gets. So I'm going to institute something that the book doesn't actually do. It says memory at MAR. I'm going to say M. So this denotes, oops, I just slaughter that R. The memory at MAR. So whatever is at the MAR, we're going to just, whatever the value is in there. So, right, there's some ones and zeros that are stored in that memory location. So remember, MAR is an address. So we go out to the address, or we got the address from our PC, and so then we put that into our MIR, and that denotes a memory location. And so we go out to that memory location, we fetch whatever's in that memory location and bring it into the IR, our instruction record or register. Okay. Also, our PC is going to be incremented. So we say PC plus 1. And I'm going to put some shorthand over here. So normally what I'm going to do is I'm just going to say PC++. I'm stealing that from Java. And so in the future, this right here, this PC plus 1, is equal to PC gets, I need to make my plus a little better here, PC plus. So if we take what's in there, take it out, add 1 to it, put it back in, that's what's going on here. So then we're just going to say PC plus plus. It's a handy little thing that they have in Java. Okay. So, and then we're going to connect these two together and go one to the next. Okay. Now let's move on to the next thing. Okay, so we're going to decode the instruction and place bits 3 through 0 in the MAR. Right, so we've already used the MAR, right? So now that instruction that came in might have an address in it. It's the IR. I'm going to do this. And we're going to go 3 to 0. So that means we're only allowing 3 bits for our memory location. That's okay. All right. So that's what gets brought in to the MAR. We're going to see this in action in a minute. Now comes our first diamond. Might not be the first diamond that we have tonight, but we'll see. Depends how far we get. We might move some things around too. Okay. So the next thing here is, does it have an operand? Does an operand exist for this thing? I'm going to stick that there. There we go. All right. Then, and so we have 2 options. Like this. That was weird. Grab the end of that. Well, it's not quite exactly where I want it. Oh, planning it. There we go. No, that's not exactly what I want either. Anyways, it's close enough. All right, so what happens if, yes, it has an operand? So remember, what's an operand? An operand means that, because some instructions, right, don't have that X. They don't have a thing in them. So, like, if we just want to get an input, right, we just tell it, do an input, and it brings in an input. So it doesn't have an operand. So in that case, right, these would be all zeros. That's how that would get stored. Very likely. Depends on, I suppose, depends on the thing. Okay. So, but if we wanted to say jump to a different memory location in our program, then that does have an operand, and the operand is basically that MAR, that data. So basically, it's asking, was this all zeros, or was it actually something that's meaningful? But it's dependent on what instruction you're working on. Okay, so then this says, I'm going to put a box on the yes here. And what this does is it says the MBR, that's our buffer register, that's going to get memory at MAR. Remember, at this point, the MAR is that address, right? That the address of whatever operand we need. And so that's what comes in. And so then we are able to bring that in from memory as well. All right. So what happens if we, let's do this. And then this. I'm going to bring this down here. And that is a no. So a no brings us back to, or brings us to that. Inside of there, we're going to say execute. Okay, well, let's go back to the yes. Ah, okay, so actually we can just do this. And okay, just undo that. Make it just a regular line here. It's going to be at an angle, but that's okay. And that comes over here to our execute. Now we're going to do, oh man, some of these lines are just not very nice. Then we're going to come down here a little bit, because actually at this point we're done. I'm going to bring this over here, and then oops. And I'll grab the end of that properly. Oops. If I grab that end and move it, it's not really snapping the way I want it, but that works. All right, and then we're going to come right on back into there. So then we'll go back to whatever is in our PC, which is this is the next location. And we kind of saw this in action last time a little bit, and maybe we'll go back and do some more things on that. All right, so one of the thing that I talked about first last week was interrupts, and kind of talked a little bit about interrupts, how interrupts work. I'm going to talk some more about that. So what I want to do is I want to say, well, where do interrupts go in this? Well, they actually go, so I get to grab this, delete that out of there. Actually put a diamond in here. Interrupt. So if there's no interrupt, nothing happens. We just go ahead and actually I'm going to move that a little closer so it's easier to read. Put that down here. Nope. No problem. Just do what we were doing before. Oh man, again, it's not snapping onto that properly. Make it do it. There we go. Okay. All right. So, well, what happens if it's yes? Grab a box here. Perform the interrupt. Handle it. That's just what I'm going to call. I'm just going to say handle it. And that's going to be different for everything, right? So each one kind of has its own way of doing things. And we'll talk about some of that. And we'll just talk about it basically here. But it's, it's something anyways. And the thing might be ignore it. In fact, actually, I've written code that throws an interrupt, and I'll talk about what that means. But then, and then in the code, it simply ignored the interrupt. It just said, whatever. Actually, I want to select that again. grab that end and bring it up here. Okay, so that's kind of how an interrupt works. Now, different systems are going to handle this different ways. So it almost certainly has to have something for unexpected interrupts. So what would be an unaccepted interrupt? Dividing by 0. Trying to do math on a string. Although, at this level, that's not going to be a problem. Because it's just data. So we don't even differentiate between a string or a... out of index. Right? So if we try to loop through something and go out of index. Although at this level, we don't have any of those controls. We have nothing basically like that. And so divide by 0 would maybe be 1. That's kind of the classic one, because that one always fails regardless of what level you're on. Right? Because overrunning a list, right, if I try to index, say there's a list that has 5 things and I try to index the 7th spot, it's going to throw an error. That's every language I've ever used is going to do that. But that doesn't... that's not going to be handled here because it doesn't know where the array starts and stops. It doesn't have any clue where it's going to end. And so it's just going to run to the end and then it's just going to keep going. Which, by the way, actually is one of the things hackers actually make use of. What they'll do is they'll inject data into, they call it buffer overflowing. And maybe you can learn some more about that some other time. But what they'll do is they'll stick things in appropriate places and it'll overrun into instructions. Because these are instructions, right? That are saved. And so if they can write instructions when it thinks it's not actually writing instructions, that's how they kind of trick security systems to be able to deal with that. This is a thought. You guys can go look some of that kind of stuff up. It's really cool stuff. Okay. Okay. So let me just kind of go down here and just talk about a few terms. Not really fired up about terms, but because it's words, but it's nice to talk about them. So we've got latency. So latency refers to, in this case, interrupt latency. So interrupt latency is how long it is between the time the interrupt got created and the time the interrupt gets handled. Because one of the things, actually this is actually pretty cool, is that I might recognize, okay, so the interrupt that comes in, well, let me talk about another interrupt. So if you press a key on the keyboard, that could create an interrupt. Depends on how the system works. It's probably what it does. It's gonna create an interrupt. Or if I click right on this screen and try to draw something. Because whatever the normal thing that's going on, it needs to stop whatever it's doing so it can handle what the user has told it to do. Right? Because remember, computers only do what people ask them to do. Sometimes it wasn't you that asked the computer. It was probably a programmer somewhere that was, not thinking about your exact situation if it doesn't do things properly. But a programmer can't read the user's mind. So as a user, you have to keep that in mind. Hopefully. They can't understand what's in your mind, but you can. But you have to know that they can't anticipate everything. So, which is why a lot of times, right, we use our intuition when we run on a computer, but that doesn't necessarily mean that the intuition of the person who programmed this or the team of people that programmed it have the same intuition that you do. So it's just important to keep that in mind. And It, which actually it's an interesting topic. Let me stop for a second and actually talk about that topic because it's actually a good one. And just do briefly here. And that is that this is why it's actually a good idea to have diverse people, diverse groups of people that are making decisions when it comes to products. And the reason for that is because the more diverse of a group that you have, the more different perspectives and different intuitions that you're going to have about how the program should work. And so it's more likely to be able to catch those blind spots that everybody has. So that's why diversity is actually really a good thing when it comes to designing software. You want to try to get your whole audience. You don't just want some of your audience, right? So you don't want a subset of it. Although you can't get everyone, right? Because say you're going to write a program that a million people are going to use. You can't interview a million people how it should work, right? But you want to have some kind of a representation of that, and you want to make sure that. So here's an example. I have a friend of mine who works in healthcare, right? And so he writes software for clinics, mostly on the East Coast. It's a big group, and he was talking. He was doing some stuff for some cancer work, and we wasn't talking about specifics. He was just talking about high level stuff. But there's like the way the doctor looks at it and sets up a prescription for somebody, but then a pharmacy has to have a different way of thinking about it because they're concerned with what's on the shelf and for this prescription so that they can send it out. And they actually don't even send it to the person. They send it to the doctor that's going to do the chemotherapy. And so then you also have the doctor or the technician that does the chemotherapy has another view of things. And so all three of those groups are going to have a different perspective on how that program needs to run for them. And so that's just one idea. But you also have different things like... somebody who's 45 is going to probably work with software in a different way than somebody who's 16, right? So it's going to be different. And so those two perspectives are also can be very valuable, right? And we can have cultural differences and gender differences and that kind of stuff too. And those are all differences in people. So and that might be, so that's why we need to try to be diverse. Okay. So this is my little plug for today. Okay, so latency. Okay, okay. I'm done talking about that. But that's the motivation why diversity is a good thing. Okay. Actually, there's another one. This is only something I heard about many, many years ago. There was a software team that was developing a program that would help people who were drilling for oil decide where the best place to drill for oil was, right? Because when they drill these wells, they want to be able to get a good well and get the right pressure and those kinds of things to try to make it more efficient. And what they did was they didn't understand the perspective, and they knew that they, as programmers, they weren't going to have the same perspective as the people on the job. And so what they did is, and I think there was only a team of maybe 2 programmers, but they actually worked for a year side by side with people who are actually doing that job. That was their first part of writing this program for them. They simply worked for a year to do it. And in that case, it was complicated enough that they needed to do that. After that year, they spent a second year developing this program to help predict where the best places were to drill. Yeah. I'm thinking of tons of other examples, but this is an example, right, where it's good. Sometimes it's good for the programmer to learn what's going on with their client, and that's the case even for my job currently, right? Is that I need to know kind of how the program's going to be used, and that comes up from time to time. I guess I can't really get into specifics. We have a portion of our program that takes. You can put in some search words, and in those search words you. And typically what you'll do is you'll put people's names in there. And then what it does is it searches for names or keywords for your company or that kind of thing. And then it searches the internet for articles that are negative about your company or about that person. And they're all public websites, but it searches for them in foreign languages and in all kinds of different languages but it's searching for negative ones. So it's interesting because one of the things I do as a tester is I have to test this. We needed to know like how that gets used. And so because there's certain ways, certain combinations that we don't have to test because it's only done in certain ways. I have to get into the weeds on it, but we were very, very curious on how that would be used, and so we could kind of limit our test space. That was an interesting one because I searched for Thomson Reuters, which is the company that's my client. That's what I do most of my work for, and I searched for Thomson Reuters, and actually it came back as a negative one with shoplifting, and so. I went and looked at this negative article, and it turns out I think it was shoplifting, but it was some kind of a crime. I'm like, man, Thomson Reuters is part of this criminal network? Oh, geez, that's not good. But it turned out that wasn't the case at all. What was going on was the detectives or the police officers that were investigating this crime had used, it was trafficking minors across the into the United States, and they used Thomson Reuters tools, the same tool that I actually work on, to actually help apprehend these people. And so it wasn't an adverse. It could have been thought of as an adverse article, but it was not. Right? It just appeared in an article that could have been adverse. So it ended up being a good deal. All right. So actually, after I've shown you a sense of how interrupts actually work, because I just interrupted my lecture to talk about something else. Well, whatever, it's fair. I think that's one of the beauties of this, right? Because you could just get a cold person that's telling you all kinds of information. But sometimes it's nice to be able to plug some of that in and be able to get some of those anecdotes and understandings and stories from people who are out there and how they do things. All right, so latency is how long it takes between when the interrupt was generated and when it was finished. In this case, probably about 10 minutes. Okay, so so hardware can actually do them. So we can say hardware interrupts. So remember when I talked about some of the input and output devices? So I suppose a keyboard would be a hardware device, but let's say it's your modem. Oh, no, let's not use that one. What do I want to do? So your printer. Printer's a piece of hardware. It's connected to your computer. It's not a network printer. Okay. So we can have a hardware interrupt. And so what it might have is when it notices that it's out of ink or out of paper. Right? You tried to print something before and it or whatever, it's out of paper. So it needs to tell you that. And so it needs to tell the CPU at some point. And so that would be handled with an interrupt. Probably. Although it doesn't have to be handled that way, it can be handled other ways. And that's actually okay. That's a. Anyways, we can have hardware interrupts, And that'll be where some piece of hardware automatically says, hey, you need to have give intention to me. All right, so then we also have software interrupts. And that would be things like system clock. That's going to be, well, actually, that can be handled either way. So it depends on the computer system. But a software interrupt, I think I might be getting better at this, although it's hard to tell. Hopefully, practice, right? So, software interrupts are called traps. Traps or exceptions. Okay. And so that would be anything that kind of causes your program to crash. But it also could be other things, like when you're sending something over a modem or through a network card. That's a better word for it. Through the network card. And say you're streaming, right? Let's say you're streaming a video. And so what happens is that video takes over the network card. It's just going to exclusively use it. And so potentially, depending on how priority you want to have that network or the network, it might say no one else is allowed to use this resource until I'm done. And so until the video is over, no email can come in. Nothing else. Nothing else can come in down that line. It is off limits, and nothing else will be done coming from the internet until I'm done with this video. Hey, it might be a really great video of a cat, right? Like a cat playing a piano, or just super cute kitten videos. Right? That's what the internet was made for, right? No. Although it usually makes me happy when I watch them, so that's good. So then we also have interrupt handlers. So interrupt handler. So it's a small program on your computer that actually deals with it. So what'll happen is, so this is actually super cool. Okay, and I'm gonna just give you a real basics on this. Is going to be something you might cover in operating systems, but we're going down through our program. We're going through this execution. Interrupt comes up. But we have to handle it, right? So we handle it. But this is what we do. We save everything that's going on currently, like what's in the IR, what's in the PC, what's in the MAR, what's in the MBR, what's in every single register, and we save all of that over into memory somewheres. And then we set the PC to the beginning of a chunk of code that's going to run through our interrupt and handle our interrupt. So then it starts executing that program, and then it'll run on that program until it gets done, unless there's another interrupt. Although most of the time when there's an interrupt of an interrupt, we pause the second interrupt. But it's possible we don't. It depends on the system. That's an operating system problem. So then it gets done, and then it goes out to memory, fetches everything, brings it in, and resume. Then we can resume back on this line right here. Okay. Those are our handlers. It's also possible, right, that we don't want to deal with them right away, and so then we'll stick them, we'll put them into some kind of we'll create a memory location, and that's a interrupt vector table. It doesn't matter. Just conceptualize it as it's going to store it someplace. You don't have to know exactly how it does that or why, or what it's even called. It's going to store that interrupt someplace else, and then it'll keep doing, because maybe I'm doing something very high priority, right? It's like, if I don't do this, the computer is going to melt. Okay, so that's about as high priority as you could get, and so it's going to run that routine until it finishes, and then it will come back and then it'll look at the interrupt potentially, but that's an operating system problem. Okay. Yeah, I don't think there's anything else more there. Okay, so that's all I had there. I think that's all I really needed there. All right, so then let's go and bring up our program that we looked at yestertime. I love that word. It's a made-up word, but whatever. I think all of you probably know what it means. Yestertime means the last time we met, which could have been Thursday, which could have been Wednesday, which could have been Monday. I'll reiterate that there will not be a lecture tomorrow because I'm going to give you guys that time to work on your exams. Okay, so what I did here is I just bring in this, and then I'm going to assemble it. So now what, in this case, this is not a good word. I don't like this word, but whatever. Assembly, we haven't talked about this, and maybe we will later. So what it's doing is it's putting it into machine code. And so machine code is actually the ones and zeros. So it converts this into ones and zeros. And so evidently, input is 5000, store X is 2007, and on down the line. Oh yeah, and then we have another 5000, which is an input. Oh, and then a 2008. That's store Y. Oh, what's the difference? Well, 7 and 8 are going to be those memory locations down here. And if we start counting at 0, here, 1, 2, 3, 4, 5, 6, or wait, 1, 2, 3, 4, yeah, 5, 6, 7. Yeah, so 0, 1, 2, 3, 4, 5, 6, 7. That's why we used 7 there. I'm not going to make you learn how to do this. All right, so we add X. Oh, look, so add must be something that starts with that 30, and then that 7 denotes our X, and then we do an output, which instead of being a 5,000 is a 6,000, and then 7,000 is halt. And it's actually not 1,000, it's actually the first digit only. The rest of it is the address. So when this gets loaded, we would expect, so this right here, this position that's highlighted, that is our value for X, which is currently nothing, and this is our value for Y. Let's see if that's how it works. Let's go ahead and do a step. So let's put our 42 here. So remember let's do something that's going to be easy to see. 7. Okay, so then I go ahead and step. Look at that, it stored it right there. Now let's do 12. Do a step. C. 9. A is 10. B is 11. C is 12. So hey, it put that C there. right where as I expected, because this is always done in hexadecimal down here. And then we do the output. I'm not exactly sure that output is working. Oh, it put it over here. It added those two together. Well, wait a second. 12 and 7 is not 13. Except for we're in base 16 here. We're in hexadecimal. So this 1 here, instead of being 10, is actually 16. So 16 plus 3 is 19. 19 is what 12 plus 7 is. And then I halt, and it's over. Okay. So let's go back to the start. Now notice that these didn't disappear. These values didn't disappear. They're still sitting there. Because memory almost never gets changed unless it has to be, which is important. And that's also something that hackers use knowledge of. So, right, if you create a variable and then you decommission that variable or it goes out of scope and you no longer have use of that variable anymore, it's still stored somewhere in your computer, whatever that variable was. It's still stored somewhere until somebody else needs that memory. And then, in which case, then somebody else will write over it. Another program will write over it. Okay. So let's just look at micro steps. Let's do some micro steps. Okay. Remember, go back to our diagram, right? Wish I could zoom out. Oh well. So it's going to take whatever's in the PC and it's going to put it in the MAR. So let's look at the PC and the MAR here. All right, so the PC is 0 right there. So I do the micro step. It just loaded that into the PC. Can't really tell that that's what it did, but okay. All right, what's the next step? It's going to take the into the IR. We're going to go to the memory location 0. Right, the memory location 0, and we're going to bring that memory location 0, and we're going to bring it into the IR. Look at that. The IR just got 5,000. Hey, great news. So let's go back here, and we say, now the MAR gets the last 3, right? So not the first one, but the last 3, and it's going to put of the AR, it's going to put that in the MAR. And we're not going to see that, right? Because the last 3 are all zeros. Now we've gotten ahead of ourselves a little bit. Because the PC is now 1. Must have missed a micro step. That's okay. So let's just put in the value 1 here. Accept. So that's our input, is 1. It's just sitting there in the input right now. I click on the micro step. What happens? Nothing yet, right? Now it stored this. It brought this. Oh, the input. That's right. We were doing the input at the beginning. Sure. That was the first thing. All right, so we're in storing. So it grabs that memory location. 2, 0, so it says store. That's what the 2 means. And then store in memory location 7, and that's in hexadecimal. That would have helped us. Oh. That's what it really is, right? Okay. So it goes to memory location 7 in hex, right? So 007. It's going to go there. So let's go ahead and step that through. So it's going to go and store that value. What value was it that I typed in? I don't even remember. Oh, yeah, 1. Why did it not store that? kind of behind the times. It's activating it. There it goes. So sometimes these aren't really on point. All right, so that finished. Oh, that finished our storage one. And what's our MAR? Look at that. See, it stripped off that first two. Okay, our PC is now here. That's the green, right? And so it says it now took that 5,000, or no, 00002, put that into MAR. It then loads into the MBR, whatever's located in that memory location. Then it took this and put it into the IR, but only in the first. In this case, it brought the whole thing. Okay. Then, so this is input, right? So it's going to decode this. It's going to ask if there's an operand. There isn't an operand. So it's going to execute the input. So then I'm going to do it too. Do my micro accept. So the accumulator gets the 2, because that just came from input, and stuck that into here. Because that's what store does. And then, oh, not store, that's what input does. And, oh, we're at the end of that thing, incremented again. So we're going to go to 3 here. And then I think you guys are starting to get I think hopefully you're starting to get the hang of this. So one of the things to keep in mind when we're doing this, because we're actually going to program some things in this, and actually some sophisticated things that are actually pretty cool. Well, let's not worry. I want to keep worrying about these, because it's important to remember these registers and that they're actually doing things. Okay, so let's try just another example. How about a multiplication one? Whoa! What happened? There's a lot more here, isn't there? Okay. All right, well, let's try it. Oof, there's a lot. Okay, I'm just going to do steps, not micro steps, and we'll kind of look at them as we go. So the PC starts at 0, which is the A000000, and that's clear. We're going to find out what clear does. It didn't do anything. Oh, we'll have to do some research to figure out what that does. Okay, store result. Go down here. Look at that, right there. Result. What's this? Result. And so that's in 0 to D, or 0 to, and then we go over until we get to D. It's right there. All right? What did it store there? It stored result. Well, put a 0 in there because nothing is in the result. The result's empty currently. And this is important because we'll run it a second time and then it'll become obvious. All right, so now it does an input. So let's do, say, 5. Let's do 5 times 3. Input, it's going to store that in this location, right? Because that's what this told us to do. 0, 0, 2, 9, 0, 2, and then the last digit here will be a 9, and that'll be this. So it'll be, that stores it in that location, and it put the 5 there exactly the way I asked it to. Okay. 3. What's our program counter doing there? Oh, okay. And our accumulator's doing a 3. The IR, the instruction. Oh, that's just the instruction that we brought in. So it brings it into here. Eventually, we can think about it that way. So now we're going to load Y into where? Into our accumulator. It's already there. Oh, if Y is negative, if dash VE negate Y and set the negative flag. Okay. So it loads the Y. Y is not negative. Oh, actually we could look at that skip condition, can't we? So that's in position. This must be the skip condition. The skip. So it says skip. And then remember, it looks at these things here. And if it's a non-zero value and the PC is certain values, then it's going to go jump to a different place. It's going to, it handles it differently. We'll put it that way. Okay. So this said here, right, we were here at this non-neg. So it's, and so if we look here, the MAR is 008. No, the MB, yeah, the MAR is 008. Why is it 008? Okay, step back. Oh, right, because that gets loaded in. Okay, let's go microstepping it. Okay, now do load the whatever is at the MAR into the MBR, and it puts it in the IR. Okay, so let's go down here and look where non-neg is. So non-neg is this. It's right there. Non-neg is, oh, because we're in this one. Non-neg is 0, 1, 1. 0, 1, 1. There it is. So it's in the process of moving things to get there. Oh, right. And so now this, our program counter, went from where it was, which was here, or it was maybe it was here, and it, oh no, 0, this one, and it jumped to here. So it jumped over all this code. And this that code here was for determining whether or not a variable was negative, or what to do if it was negative. Right? So if it was negative, it's just going to go ahead and skip kind of the next thing. Oh, okay, that's what skip condition is doing. It skips the next thing. And then the thing that you skip is usually a jump to someplace else. Okay. I'm getting the hang of this. So now we are seeing this, right? So we went down here and we did a clear again. So we just cleared I think we're just clearing that accumulator. So then it's going to store the neg flag. So neg flag is down here, and that should be 0. My guess is it's 2 after this one, so it's going to be right there. Oh, we stored the value 1 right here. Oh, that's interesting. We'll see how that works. All right, so we go up here. Check if y is 0. If it is, then we jump to the halt. So we're going to load in y. Right, that just comes from here. That's that 3. And we're going to skip to, we're going to skip condition. This is, we'll have to work on how that works. That 4, 0, 0. But in this case, right, we know it's not 0. So it's going to skip. Oh, this tells us how many lines it's going to skip, I think. Yeah, I think it might have something to do with that. So it jumps past both of these two. Even though this is still pointing at that location where that loop starts, or the jump starts. That's okay though. Alright, so here's our loop. Oh, there's a lot more there. So it loads the result. So it brought the result, which is here, and brings that into the accumulator. And then it's going to step again. And then it stores the result. Or it adds X, sorry. It adds X to the accumulator, right? And then it stores that back into the result. So we're gonna see this result, which is, if I remember right, 2D, right? So we know it's right here. So that's gonna change to be a 5. 0, 0, 0, 5. Okay. So then we go down here and we load y. And that was that 3. That's now in the accumulator. We subtract 1. Aha, look at that. Went down by 1. Remember, see, this is 1. That's why we had to keep that value 1. And so then we have to check to see if we've completed the multiplication. In this case, we haven't. So we're going to go back up here to the loop again. So look at the PC counter here. That's going to jump. That's going to go up to here, and that'll be, yeah, it'll turn into 1, 7. There's our program counter, jumping right up to where we expected it to go. But the AC didn't change. It's still the same from the last time we did it. So we load the result. So that's a 5. That goes into our accumulator. And then we're going to store that. We're going to add the X. X is 5. So 5 plus 5 is A. That's normally what you guys get, right, when you do that in math class. And so, yeah, right, because we're using hexadecimal. That's the reason why. Otherwise, we could change it, but it doesn't matter. We should be. It's good to get used to it. All right, so then we're going to store that in the result, and remember our result is right here. So then that A gets stored there, and then we load Y. That'll be a 2, and then we subtract 1 from that. We're going to get to a 1 in our accumulator right there, boom. And then we're going to store that back in Y. So now this is going to go to 1. Oh, I don't like this algorithm. Not very good. Okay, so then it checks to see if we've completed. We have not. So we're going to jump back up to line 17. Or, sorry. Yeah. It's not 17. It's 0, 0, 1, 7. Or no, 0, 1. Yeah. 0, 1, 7. Yeah, that's the location we're at. So that's what we get. So then we are going to load in the result again. And we have that A there. And then we're going to store that result. Or no, we added 5 to it. And A plus 5 is F. F is 15. So then we're going to step again. We're going to save that out here. And we subtract 1 again. Load our Y. And then we do our subtract 1 from it. Then we store back in Y. Oh, look at that. It went to 0. And then we're going to check to see if we're done. That means that those are zeros. We are. So it jumped past that stuff. And it goes down here. and it says now load the negative flag. So we're in 1F. So we're here. So this tells us to load the negative flag. So where's the negative flag at? 02C. Right there. That's the negative flag. Notice how it got highlighted there. It loaded that into the accumulator. It then says, hey, is this end, is that 800? Yep, it is. So we're going to skip the next thing. Oh, no. We're not going to skip the next thing. We don't skip if it's equal to. So then it goes to this one here, and it says halt. Oh, jump to halt. Oh, look at that. We jumped down to halt, which is there. So we jumped to that spot, and so we load the result in, F. We output the result, F, and then we halt, which is that one. No, this one. This is halt. And that's it. So hopefully that's that kind of walking through some of that. I think this is a really good way to do it. It's not perfect. It's not the best way to kind of see it. Notice I've bookmarked my Maria here. Oh, you guys can see my bookmarks. Oh, is that horrible or what? Yeah, maybe. Well, most of them aren't a problem. Well, only this one, maybe. All right. Yeah, I don't think there's anything more to talk about here. We're getting a sense of kind of how the flow works, and we'll maybe I'll preload one for next week. But we just want to get a kind of a sense right now. It's not a major thing. We're not going to start coding in this just yet. But we want to get a sense of a little bit about how it works. And so there'll be an assignment next week that'll be about kind of how Maria works and some of the different things, and talking about interrupts and those kinds of things. So, yeah. So make sure. I want to talk one thing on the exam. I ask you to tell me about the resources that you used, and I really am honest about. I want to know, and it's not a trap, right? So don't think it is. It is just I want to know. If you answer that question, regardless, you'll get full credit. So, but try to answer it honestly, because I want to know what you're using, because I think it's useful because you guys are finding things probably that I might find useful, or maybe some of your classmates find useful. So, right, if it's a resource like it's a book or it's a website or maybe some videos, those are all great, and put those in there, and that's a good thing. And in this case, I'm actually going to give you credit for it. It's only 2 points, but hey, 2 points is better than no 2 points, right? So, take it, and you can think of it as extra credit because the exam is 102 points, but I don't think extra credit, because to me all credit's the same credit, and so I don't call it extra. Although you might think of it as extra, but it's not. It's because I don't grade on percentages, so it's not a percentage thing. I don't necessarily grade on percentage, so there is no such thing as extra credit. So this exam is worth 100 points, but you could get up to 102. Although my guess is it would. Well, we'll see. I hope somebody gets 102. We'll see. It's because it's different, right? It's going to be different because of the take-home part of it. So, all right, I expect to see good work from you guys. I will for sure be grading the exam right away, and so do not be late with the exams, because if you are, you will not be happy. So that because my late policy is in place for being able to redo things for the assignments, but not for the exam. So make sure that that exam is in on time. I should probably send out an email on that. I'll do that right now. Okay, that's all I have for tonight, and we will see you next week. Hopefully everyone stays safe and has fruitful work between now and then. And try not to get too cold if you're outside in the evenings or in the night, because it's supposed to get down a little bit chilly. If you were a tomato, you might not be happy outside today. So most of you are not tomatoes, so that's a good thing. All right, talk to you all later in a couple days.